Hi everyone, I'm Meghan Sullivan and welcome to this quick video on Nier Replicant version 1.22474487139. We're going to get to the root of the problem, historical root of the mathematical problem that is. The name Nier Replicant version 1.22474487139 caught a lot of people's attention due to its long string of numbers and possibly deep meaning, and fans quickly calculated that 1.22, yes I'm rounding here, is the square root of 1.5. And that actually makes sense. According to an interview given by the series creator Yoko Taro, the game is a, quote, version upgrade of the original, not a full-blown remake or remaster. So having a number that represents a space between 1, the original, and 2, being a remake or remaster, is a clever way to advertise what the game actually is. And it got me thinking about square roots in general, which is odd because I hate mathematics. I'm terrible with numbers, but I'm very good at history, and I got curious about the history of the square root and decided to do some research on it, and I found out a couple of interesting things. For example, the square root symbol that we all know and love, well I don't love it, was first used to represent taking a square root by Christoph Rudolph in his 1525 text Cross. This was also the first text, by the way, to use the plus and minus signs to represent addition and subtraction respectively. Before that, in 1450 AD, a man named Regiomontanus invented his own symbol for a square root, written as an elaborate R. If we go back further, in the Chinese book Writings on Reckoning, written in around 200 BCE during the Han Dynasty, a method for determining square roots is outlined. This is one of the oldest Chinese mathematical texts, and outlines concepts such as calculating interest rates and finding volumes, in addition to determining square roots. But communities in ancient India were using square roots as early as 800 BCE. This is documented in the Baudhāyana Sulba Sutra, one of a series of texts that cover subjects from religion to mathematics. Meanwhile, the Yale Babylonian collection has a tablet from nearly 4,000 years ago that depicts the square root of 2 out to 9 decimal places using a square and 2 diagonals, which may be the oldest proof we have of humans calculating the square root of a number. But the other super early evidence we have of the square root being used comes from ancient Egypt around the same time. According to St. Louis University, the Egyptians were one of, if not the earliest people to use the square root, which they called the khembet, for architecture, building pyramids, and other daily activities that required math. The Egyptians represented the square root with a right-angle hieroglyph. Perhaps because the square root was similar to, say, the corner of a box, it was, quote, the root of the area because it had equal lengths. It's thought the Egyptians kept tablets with references for basic square root problems on them, but we haven't found any yet. The good news is we do have papyrus like the Mathematical Papyrus and the Rhine Papyrus, which feature 112 math problems with solutions, although often without explanations of how the solutions were computed. But they do contain problems for square root equations, which is impressive. Now you'll notice I'm actively avoiding breaking down the specificities of how each world culture went about discovering and solving the square root of a number, because the methods are different and they're all intimidating to me. Look, all I can tell you is the square root of 4 is 2, the square root of 16 is 4, the square root of 25 is 5, and the square root of 100 is 10, and that's all I can tell you. Let's just say that the square root has been discovered by many different cultures over many centuries, and that it's all pretty darn useful. At any rate, this was just a quick fun little video on the history of the square root. I hate mathematics, so I'm not going to do a deeper dive into numbers because I'll scream. Thanks so much for watching, guys. See you later.